this word inline, right? It is used to express this function could be inline. So what does inline mean? So if it's a typical function call, right? If it's a typical function call, we said when we call this function, a temporary stack will be created, right? And then some temporal data could be put inside of your stack, and the return values could be put into your stack. And when the function call ends, when it returns to the whoever is calling your function, right? You need to destroy this stack and returning the values back to the someone who using your data. And we said calling a function is sometimes it's expensive, right? Especially it involves the memory operations. So people would think, how about I'm not using a function call, right? Instead, when I am writing it in this way, can it be replaced by the body of your function instead, right? So when you are calling this function t.getSeconds, getSeconds, it will return the second. Second belongs to the time object, right? Which belongs to t. So you can access t.seconds like this, right? We're not talking about writing your code in this way, right? You cannot write your code like this because the second is a private member of your time class, right? You cannot write your code in this way, but you can write your code in function call, right? t.getSeconds, as long as this is a public interface, we could do that. We put an inline here so that the compiler, right? The compiler will replace the function call with this line. Instead of calling a function, we immediately access the data. So there will be no function call here. There will be no stack created, stack destroyed, that kind of expensive operations. So that is the benefit of inline functions. And we put a probably here, is saying compiler may do that or may not do that. The way to check that is by looking at the assembly code. But since this class is not talking about assembly code, we just trust the compiler, right? Sometimes trust the compiler might do their best effort to modify the expensive function call with the real function body in here. So this is what we mean by inline, right? Replace the function in line with the function body. So this is called inline. All right, this is called inline. So how can we do it? For instance, this is our product class, right? This is our function, for example, getName. And here is what do we call this function, getName. Let me make it 2 parts. All right, so we have a function here, right? We can define it as inline function, saying, okay, this one is inline. And we need a class name because it's defined outside. So we have product, column, getName, returning the name. And here we don't give the implementation details. All right, so now it is an inline function, right? It is an inline function getName when it calls getName. And this one might be this way. And also it might be replaced by the compiler with this line, p1.name. So again, if you write the code in this way, it will be some error because name is a private member. But if a compiler do that, it's okay. Right? If compiler sees you are calling a function, which is an inline function, it tries to replace your function call with the function body. Even if it's accessing its private member, it's fine. All right. This one is done. This one is done by the compiler. You don't have to write your code in this way, right? But indeed, what's happening is this line becomes this line. Right? After compiler compiles your code, it becomes your binary code. It is doing this kind of optimizations. So that's what we mean by inline. All right, so there's another way to write an inline function, which is like this too. So instead of defining this function to be inline, like the getName, and define it outside of your class definition, we could simply write the content of your function, right? This is the function body, right? The content of your function inside your definition, inside your class definition. If you do that, you are implicitly telling the compiler that here is an inline here, right? So that is a explicit way, not implicit way. This is the explicit way of defining an inline function. This is also another way to define an inline function, right? And when you call get price, compiler will maybe try to replace get price replaced by, for example, p1.price. Similarly, get score will be modified by this, and set price will be replaced by this. All right, so let me write it down here. So if it's p1.set price and 10, what compiler is doing is p1.price assign as 10. Right, as you can see, this set price here, this is an inline function because it's defined, the function body itself is defined inside your class definition. So it is a inline function. And inline function, this compiler might do this optimization, right? Instead of an expensive function call, it is replacing the body with its inline here, right? So in this way, you are not calling a function, you are just assigning to some variable. So that will be much cheaper. So this is also something compiler will do. As you can see, we have two ways, right? Two ways to specify one function as an inline function. And we said inline member functions have to be defined in the header file. They have to be in the header file. And if you learn compiler more, you will know why, but I'm skipping that. So I'm not trying to confuse you. So inline functions, as you can see, I'm defining inline functions in here, right? Instead of in the CPP file, I'm trying to put it in the header file. So that's something you need to remember. Right, so we have two ways. One is explicit inline, right? Put inline before the function definition. Another way is just to define the function inside of the class, right? So like this one, get a second. This one we are not saying it's inline, but a compiler might treat this one as an inline function. So that's the implicit way. As you can see, sometimes people tend to write all the if the function is too long, right? They tend to write everything in just the class definition. They think it's easier. They don't have to write the CPP file. But we said it may hurt the readability of your class definition, right? If it's too long. And we said it's a common practice to put the implementations to the CPP file if this one is longer than, for example, 1 line or 2 lines. Then if it's, for example, hundreds of lines, you put all of them inside the header file, people might get confused might find it hard to look for something inside your time class. For example, in here, if I have a print function, right, that is 100 lines long, right? If it's too long, it is very hard for the people to find out, okay, what is belonging to product, right? It takes some time for them to figure out what's inside here and what's not in here, right? You're trying to make your public interface. Very concise and easy to see, right? As long as people see this file, they know how to use your code. So sometimes this one are a typical header file is written like what I do. If this one is just 1 line, you write it here, right? If it's more than 1 line, put it in another CPP file. So that is what do we mean by inline functions. So we quickly cover that. So inline, we said it's just a hint to the compiler. You tell the compiler saying, this function might be benefit to replace inline, right? Replace the function body with the function call inline. So it's just a hint. Compiler might ignore your suggestions. So it's just a suggestion, right? You said, okay, how about put this one inline? But if compiler thinks it's not so benefit because you are making the code longer, right? You are replacing function body. If the function is, for example, 3 or 4 lines long, you are replacing everything in line. that make your code longer. And the compiler sometimes think that might not be benefit, so they might change it and use the original function call way, right? So that is what a compiler can do. And there are many ways to optimize your compiler, or you can utilize their let me see. So in a general compiler, you would say G++ and compile, right? And then you can say, okay, -O3, you want your optimization level to be, for example, if you don't want any optimization, -O0. If you want some optimization, -O1. If you want more optimization, -O3. So compiler will try their best to optimize your binaries so that it runs faster. All right, so you can try that in your terminals, but I'm not too sure about how it is done in the IDEs. Anyway, this is the inline functions. Any questions about inline? No? All right. So the last topic we want to talk members. So we have already seen static before, right? Let me test this out. So in here, let's see, what we have done is, if we want to know how many times test class is called, we can do something like this, right? And let me comment them out. First time called, second time called, third time called, right? And we can see out this count. When we run it, we will see 1, 2, 3, right? Instead of being a normal variable, which is initialized to be 0 each time when the function is called, we are indeed keeping only one version of count, right? There's only one version of count. This is static means one version, right? Static is one version of count. So each time you are calling this function, the count is only initialized once. The first time this one enters, the count is initialized. After that, this line is ignored, right? It will not initialize it to be 0, but they are incrementing the same count over and over, right? So that is the way we are keeping track of how many times this function is called. And we can do the same for our class. So let's see. For instance, we have an account, bank account, right? And we could define some variable, some members to be static. And also we can define some functions to be static, right? This is the member, this is the member functions, right? They can be static. So again, static means only one version, only one version. And we said that a class, right? A class is like the human, right? It's a class, and each object is like an individual person. Each individual person has a name, but a human don't have a name, right? The class don't have the name. But if it's a static, it means only one version for the whole class. So the class has a count. Has count. Let me just make it a count. All right. So account has count. Let me do this. So this account has count, right? Because it's a static, it belongs to the whole class instead of each individual object. It belongs to the whole class. So what you can do is, because this one belongs to the class, each individual object can access it, right? Because this one is a common property for the whole human, right? Then each person should be able to do that. And also this function should be able to accessed by each object. But the name, the property for individual object, the class cannot access it. Let me explain what does it mean. Let me try it in here. Create an account, A with name A, B with name B. Now there should be two accounts, right? So let me see. maybe I can create a one by one. If I have this and I am trying to see out a dot get count, that's one. Then I'm trying to output, create another account. Let me output a dot count and output b dot get count, right? Let me run it. So as you can see, when account A is created, when you output a dot get count returns this count, right? Because when you are constructing this object, you are incrementing this count. So initially, we assign it the initial value to be 0. After the first object is constructed, this count becomes 1. So when you are trying to output the count, it will output 1, right? And then when you are trying to create a new account, the count also increment. As we said, count, there's only one version for the whole class, right? For the whole account. Instead of, it doesn't belong either to A or to B, it belongs to the whole class. So when B change this count, it also change A's count, right? It also change A's count. So when you say A dot count, it becomes 2, and the B dot count is also 2, right? It is because this count is belonging to the whole class. Let's show it in this way. Instead of using an object to call get account, we could also say account get count, right? And let me copy this one to here. Right, so when you are using your object to calling get count, it can return this count, or you can use your class name, right? It's very weird. We haven't seen this one before. Using your class name, column, get count, right? It can return 1. It can return 1. And when you are creating a new one, as you can see, it changes all the counts, right? Either you're calling from A, calling from B, or calling from the class. It is the same. It is the same. They belong into the same count, right? There's only one version of count. So as you can see, this one is the static member, right? There's only one copy. This one is a static. You are trying, what does this function mean is basically, I'm trying to return something that is static, right? So this function should be able to be accessed by, the class, right? Class name instead of each individual object. So what does it mean is, all right, assuming, let me remove them. For instance, I can do this way, right? How about in here, instead of doing this, I'm doing, for instance, name.length plus this one. Right? How about this one? There will be some errors. Let me make it longer. In this static member function, right, I'm returning name.length plus count. As you can see, I'm trying to combine the non-static variables with static variables, right? Non-static variables with static variables. I'm trying to access non-static variables and static variables. Then this function cannot be static, right? This function cannot be static. Why? It is because if you are trying to call this function using your class account, column, get account, and when you call it, it doesn't know what is your name. We said that the whole class don't have a name, right? Name belongs to each individual object. Name belongs to each individual object. So if you are trying to write a static member functions, you cannot use non-static variables, right? If you really want to use it, this guy cannot be a static function. It cannot be a static function, right? If it's not a static function, then you cannot call using your class name. you should call something like a dot. Then your function knows what is a name and what is count, right? Like this. So this one is valid. But if you want to make it static, you cannot use non-static variables. It's because class don't know that. If all these variables are belonging to the whole class, right? You could use your class name to call this function. So this is something about the static member functions, right? Any questions? So static members, right, are the same as what we have talked about before. It means there's only one version in the current scope, right? In the account scope, there's only one count, like this one. In the test class scope, in this scope, there's only one version of count, right? There's only one version of count. And in the class account, it also has one version of count, right? It's not a global variable. Don't mix this one with global variable. If this one is a global variable, they will fight each other, right? Your count and my count, they will be fighting each other. There will be a duplicated names or redefinition of a count, or redefinition of count, right? But they are indeed defined in their own scope. But static means only one version for the whole scope, all right? So similar in here, count only one version. And when it's static member functions, you cannot access the variables that's not belonging to the class, right? If the members are belonging to one object, you cannot access them in your static members, because static functions should be able to access by the class name, by the class name. This is something you need to remember. And also, here is how you can initialize the static members, right? Instead of using the constructor to initialize them, right? Let me try this one. Right. How about we initialize count to be 0 inside our constructor, right? You might think, okay, how about I initialize it to be 0, right? As we have written before, every member could be written in here, right? Member count can be written in here, but there will be some errors. Compiler will complain because count is not a member of an object. So you cannot initialize it in here. Here is for initializing your object, initialize the members of your object, right? You cannot write it in here. The only way you can write it is inside the function body. Function body, you can do anything you like. It basically means count is not a member for each individual object, right? So it means you cannot initialize it in here. It doesn't belong to the object. So that's the this one, and it has to be initialized outside of your class, right? It should be initialized here. So that is something you can remember. All right. So any questions? It is also a very useful. It is a very useful global variable, right? Sometimes if you want to use a global variable, but you don't want to mix the names, this one can be a global variable, right? Sometimes you can replace your global variable with static members of your class. You can do that. And each time you are trying to modify it, just account, column. For example, get name, set count, get count, do something like that. Right. So we have done this part, right? Create two objects, then calling a.getCount, calling b.getCount, calling account.getCount, right? So these are different ways to access the static function members. All right, so the last one is some exercise that's, I would say it's pretty simple. It just asks you to implement something that's more realistic. So for example, we are trying to implement a class called car, right? It has a fuel efficiency. And it means for every liters of gas, how many kilometers can you drive, right? Assuming this is the efficiency you can define for every individual car. And then, for instance, you can add gas, 20 liters, you can drive, for example, 100 kilometers. And after you drive 100 kilometers, how many gases are remaining. For instance, you can get the remaining gas. And also you can implement a class called a gas station, right? Gas station, it has a price. For example, it's 100 per liter. And then you can compute if I want to add 20 liters, what is the price, right? And also you can create some problems such as if you know the distance of all the gas stations, right? If you know that, and also every gas station has a price, right? Every gas station has a price that is inherent to every gas station. And then you can choose which one should you choose to add more gases to your car, right? You have to consider the distance, you have to consider their price, you have to consider the gas you use in the way back home as well, right? So this will be very simple. So I would skip this one. All right, so that's basically everything we covered, and also everything will be covered in the midterm. Next one I want to mention about is the exams. So for the exams, we have the classroom. Wait, this is not this one. Location, right? Because we have 4 parallel sections, and each parallel section we will take one classroom. So for our section, we will be in W1 101. It's not this classroom. Right? Don't come to this classroom. No one will be here. And go there. So you should be there at least a few minutes before the 10 a.m. All right. So be there on time. Yeah. So that's basically the details. And also people ask me to explain a little bit about our sample questions. Let me see, do I have the sample questions? Yes. So here are the sample questions. All right, so first one, wait a minute, so first type of questions are called multiple choice, right? You have multiple choices to choose from, right? You can choose A, you can choose B, you can choose C, you can choose D, you can choose E, right? It's called a multiple choice. You have multiple choice, but you only have one answer, all right? You choose either A, B, or C, and it's not multiple answers, it's multiple choice. All right, so what's the output of this expression? So we can think of this one as integer divided by integer. So this one should be 0, and a 3.0 plus 0 is 3.0, right? Even though if you are trying to see out it might output 3, but basically, you know what we mean, right? We are asking you to test, do you understand what is integer division, right? Do you understand integer division? So you should choose, for example, A. And as you can see, this one are more related to the programming indeed. We have other type of questions. It's still multiple choice questions, but it's more related to the concepts. The concepts we discussed, some of them are very hard to test using programming, right? So we will make them a few of them, maybe 2 or 3 questions are related to the concepts. You have to understand what we have talked about in class and the basic ideas about the basic concepts and many of the materials, right? We have covered a lot of materials. Everything we covered to today will be covered in the midterm. All right, so that's about the concepts. So yeah, this one, and next part is about reading a code, right? Reading a code, and also take out, for example, a piece of paper to maybe writing down something. For example, if you are trying to mimic what this code is doing, you should be able to, for example, follow this for loop, right? What is this for loop doing? It's iterating through all the characters of your string, right? Iterating through H to E to L to L to O. And then in your mind, there will be some instructions running, right? Your mind becomes your machine. So you are asking, okay, what is this part, right? If you don't understand what is the these 2 ampersands, right? It will be a trouble, right? If you think this one, what is this one, right? So then you will be in trouble. If you understand this one means it is true only when both the left and the right are true, right? So if you understand this one, then you have to understand, okay, how about the characters, right? ASCII code. If the ASCII code is between A and Z, what does it mean, right? It means lowercase alphabet, right? So if it's lowercase alphabet, then you have to understand what is continue, right? What's the difference between continue and a break? You have to understand, right? If we say break, what is the output? If it's continue, what is the output, right? You have to understand that. So if it's continue means we will skip all the characters between lowercase a to lowercase z, right? So in that case, we will continue and we will not increment your count. So basically, we will ignore the remainings, right? Only the first H we will increment your count. So the output should be 1, right? So that is, it's asking you what is the output of the program. Basically, you have to explain a little bit about it, right? Why this one is 1. You can say, okay, because this line will skip the lowercase alphabet, and then the output is 1, right? Something like that. So we have many more questions similar to this, asking you to read the code, right? And ask you, what if this one is this? What's the output, right? So something like that. And I ask you, what's the behavior of the program? You have to explain a little bit about what is this one. And by the way, you can only write English, all right? Don't write Chinese. So the most difficult problem might be writing the code on your own, right? Because you don't have your debugger. Sometimes you will make a mistake. We can tolerate that. As long as your main ideas are correct, we will give you a majority of the code, majority of the points, right? So for instance, this kind of problems, and it says write a C++ function that prints the first number that is larger than n, right? We have writing down the interface for you. We have writing down the main functions. The only thing you need is fill in whatever you think it should be there. Sure. So this one, I would say this question is relatively medium or easy, right, compared to what we have in your exam paper. So let me ask, what do you think about this problem? Do you think you can finish it in 1 or 2 minutes? No? All right, so let me talk about this one first. Let me copy and maybe I don't need to copy it. I can remember majority of the code. So let me create this. All right, so what you're asking to do is you have an n, you ask the user to see in this n, and you are trying to output get first prime of n, right? So you are trying to implement a function called get first prime int n. This one, right? So what does it mean? It should be greater than n. So let me increment n first. Then I'm asking, okay, is n a prime or not? Right? If it's not a prime, I would increment n. Otherwise, I would return n. So if you can write some code like this, even though you don't know how to implement this function is prime, right? You can write something like this. Okay, Boolean is prime is a function, take integer number n, and let's say here you can say returns true if n is a prime number. All right, and then you says, okay, return true. If you write a code like this, right? Even though your is prime function is wrong, but your basic idea is correct, right? You have a function that is doing returns true if n is a prime number, right? And how can you get the first number greater than n? You first increment n, then you are testing is n a prime or not. If it's not a prime, you increment n, and if it is a prime, you returns n, right? So your basic idea are correct. You will get at least half of your code, half of your point for this question, right? Get the idea? Try to modularize your code, and for some part you think it's really hard, right? And then try to make it a function, and then writing down some of the comments, and also, for example, implement the remainings. All right, so we might give you some points on that. Yeah, it really depends on whether you can hit on the critical points, right? If some of the key parts you can implement, like this one, these are one of the key parts, right? If you can implement this one correct, you get some points. And if you delete this one, then you need to implement S prime, right? In order to get all the points. So this one, we have done it for many times, right? Int I equals to 2, I less than n, plus I, if n mod I equal to 0, return false, right? Something like this. So this one, we have done it for many times. So I would say this question is relatively easy because this function we have implemented many times, right? So yeah, you can test this one. Of course, in your exam, you cannot test it, but you should, like reading the code, right? You should do it manually, right? If I am inputting 5, let me go it step by step, right? Now it becomes 6. I'm testing is 6 a prime because it's not. I increment, now n becomes 7. Is 7 prime? Yes, I will finish this while loop, then I will return 7, right? You basically need to follow it step by step to test whether the code you write is correct or not. So that's this kind of questions. So any questions on it? You get the point, right? Try to get partial points, even though you don't know how to implement all of them. All right, so we will have many questions related to writing your code on your own, right? As long as while you are doing your homework, as long as you are not copying code from GPT, from others, as long as you practice for many times, I believe most of the code you can write on your own. So that's this part. So another thing people ask me to talk about is the homework. For the homework, let me see here. Wait a minute. Let me log in using my account. Oh, it's already closed. Yeah. So we can see it in here, right? First one, polynomial multiplication, right? So for this question, these are someone submitted after this homework. So anyway, so we are giving 2 vectors, right? Vector 1, vector 2. They are, I'm not sure whether they are in order or reverse order. Let me see if it's a 1, -1. All right, this is the reverse order I would like. So I would typically write my polynomials like the first element is, for instance, let's forget about this one. All right, I would typically write my polynomial as a0, a1, a2, blah blah blah, right? Which is a0 plus a1x plus a2x squared. And we have a b0, b1, b2, blah, blah, blah. It means b0 plus b1x plus b2x squared, and so on, right? When we are trying to compute this multiplication, right? And the only thing we need to do is, for example, doing them one by one, right? For every 2 coefficients, we just multiply them together, a0 and b0, right? Now we have them multiply them together, and we need to put them in some place. For this one, they should be in the position 0, right? Position 1, position 2, position 3, position 4, and so on. So when you multiply this one and this one, it should go to position 0, right? If you multiply a0 and b1, it should go to position 1. If you multiply a1 and b0, it should also go to the position 1, right? So you need to do it manually. You need to do it manually instead of directly implement it. So let me see if I can implement this simple one. So assuming we are returning a vector of integer that is doing multiply, which takes vector of integer polynomial 1 and vector of integer polynomial 2, right? So assuming we have the result, we have the polynomial, and we are trying to return this polynomial. And in between, let's say, the first one, we need to decide the degree, right? Let's make the degree larger. It could be a little bit smaller anyway. Polynomial 2 dot size. All of them initialize with 0, right? First one, I initialize all the coefficient to be 0. I'm creating one polynomial, which is 0 plus 0x plus 0x squared, right? And we can iterate through the polynomials. Less than polynomial 1 dot size plus I. That's 1. And then let me create another one. That's polynomial 2. Right? And we want to figure out where should poly 1i times polynomial 2 of j, where should it go, right? We want to find out if I multiply polynomial i with polynomial 1's I with 2's j, where should the coefficient go? So you need to do it, for example, on your paper. You will find out it should be in here, right? So that's this. So it should be in the I plus jth position, right? If all of them are 0 and 0, it should be in the 0. If it's 0 and 1, it should be in 1, right? You are basically adding them to the relative coefficient. And when this one is done, the whole thing is done, right? For the remaining program, you need to figure out how to print it, right? Because it may contain a lot of zeros in your polynomial, in your vector of integers. The only thing you need is print it, right? So this one is relatively easy, I would say. But it's slightly different from this this question, right? Because this one is in the reverse order. It is 1 first, then -1. I would typically write something like -1 first, then 1, right? But it's also very easy to figure out where should the position go. You can try that. So this one is the first question. Next one. This one, a lot of people ask me, how can we solve this problem? The magic square. So in the magic square problem, indeed, this one, we are making the problem simpler because we're restricting, there will be only 3 missing values. So a typical magic square problem would be arbitrary missing values. If there are arbitrary missing values, you have to do something like the recursions and backtracing. But if it's only 3, you can use brute force. You can try all the different combinations, right? Because all the values, you know the range, right? Between 0 and 100. Or something even easier, if some of the questions ask you to restricting the values to between 1 and the n square, right? Then the problem will be much smaller. But if it's, for example, 1 and 100, then what we can do is, let me close them out, close it, close it. All right, so we can, for instance, the most important thing is about a Boolean function. We are trying to figure out, is one of our ways to fill in the locations, are they valid? So assuming we have a vector of vector. This is the board we have already filled in, all right? And we want to try to figure out, is it correct or not? Let me just return true. And you can try to figure out this one because it's basically doing compute the sum of rows, compute the sum of columns, compute the sum of diagonals, and check is there any mismatch between them, right? So this one is something you can write. It's very similar to the n queen problem, right? If you want to fill in n queens on your board, the first function you write is check if this is the way I put my queens, is this valid, right? If you have such a function, what you can do is, for example, if you try to fill in your this one, right? What we would typically do is, okay, let's try I from 0 to 100 if it's inclusive, right? And then plus I. This is the first one, second one, third one, J and K. Here, what you need to implement is fill in the empty slots with I and J and K, right? And then I would skip this part here, and your testing is valid of your current board, right? If it's valid, we can return, right? Otherwise, at the end we are returning, for example, no solution or something. So these are the basic steps. We call this one a brute force solution. So brute force means try all the possible combinations, try all the possible solutions, right? It's very similar to this one. We are also try all the possible solutions, right? From n to n plus 1 to n plus 2 to n plus 3. Try all of them. Here, the same. Try all of them. When I equal to 0, ijk 0, 0, 0, 0, 0, 1, 0, 0, 2, right? 1, 0, 0. Try all of them. And because we are fixing the range to be 0 to 100, right? You can count how many times this loop body is executed. It's 100 times 100 times 100, right? It's 1 million. Because our machines are very fast. Right? Our machines are, for example, gigahertz. Gigahertz means each second it can do billions of operations. So you can count on your machines to finish this one very fast, right? So because our class is not an algorithm class, we are not asking you to implement something very efficient. You can use brute force. You can try all the possible ways. It's totally fine. It's also fine in your exam, right? You can write something that's only using brute force to figure out what is going on. And the main thing in here, maybe just to fill in, then check if it's valid. And the end, you may, yeah, I think that's basically it. So I'm not going to complete the whole program because it takes some time. But anyway, that's the basic concept. Any questions on this one? This problem is easy because we are restricting the number to be small and only 3 missing values. All right, so that's also when we are designing this problem, we are trying to make this one simple because at that time you haven't learned about recursion yet. But if we are saying, okay, this one has to be any integer number, right? You cannot say to the power of 64, right? To the power of 64, then it'll be a problem, right? Looping this amount of times, it doesn't make sense. Your computer wouldn't finish. It'll be time limit error. So if it's just 100, no problem. You can do that. Just a few for loops. All right, so for this one, we are done. And the last one is the gossip. So this one is about starting from someone, right? Let me see. There are n people, 6 people, 5 relationships, then k rounds, right? 2 rounds. And the starting position who knows the gossip is people 1, right? And here we define a bunch of relationships. So let me copy that. Let me just test the first case. All right. So vector of int. Let me call this one a relation. It's a bunch of stuff. 1, 3, then 2, 4, then 3, 5, then 5, 6, then 1 and 2, right? So that is the relationship. And I would introduce my way to do it, but there should be multiple ways to implement this one. So let's call it spread. And let me see, taking the relationship and the person who knows at the beginning, let me see, int person equals to 1, right? And the number of rounds, int rounds equals to 2. What else do I need? Yeah, basically it. And assume I will take something called Boolean. It shows me which people knows it, right? So I want to implement some function that's spread starting from a person, and after rounds, so many rounds based on the relation, it will return to me a Boolean factor. It tells me which person knows it, right? And at the end, I want to print it. Boolean k, assume it's known, see out the k. Let me use a empty slots, and I'll put a new line. All right, so that is the main part. And I want to implement this function now. So it will return a Boolean, and the function is called spread. And here are the parameters. First one is the person, and then the relationship. Let me give it a const. I don't want to change the relationship when I am doing it. And here is the final round. Wait a minute. Right. So this is what we want to do. And assuming initially no people know them. Oh, maybe I need the total number of people, right? Total number of people. Total is 6 people. Int total, all of them doesn't know anything. Then I can assign known of person to be know it, right? And at the end, I want to return this factor known. So in the middle, I want to modify this factor, which keeps which person knows it. So initially, I make them all of them false. They don't know. And at the end, I would return it. So in the middle, I would like to have a few rounds, right? Int round equals to 0, round less than round, plus round. These are a bunch of round. I want to do it. Let me see. So in here, right, for every round, we need to figure out who already knows. So let's do that. We need to figure out who already knows it, right? If the people I already knows it, we need to spread from the person I. So let's call it spread once, spread 1. Starting from person I, we wanted, maybe they need to know the relationship, and the factor no, all right? So here, assuming I already have this function, right? It means if I already know I, if person I already knows it, I want to spread it. Then at the end, the no factor should keep track of who knows it, right? But there's one small issue is our factor starts with 0, right? But our person starts with 1, 1, 2, 3, 4. So what we can do, one trick we can do is we can make the size slightly larger. And so that if there are total 6 people, we can make the size 7. And we will waste the first element, right? No 0. No 0, we will never touch it. But we will start from no 1 to no 6. Then we can assign no person to be true. This person, if it's 1, it's no 1, right? So let me check that. If I don't implement anything, it should be only person 1 knows, right? Only person 1 knows. That is what is we are expecting, right? Only person 1 knows. Because we are making the 7, 1, 2, 3, 4, 5, 6, 7, right? We're making the vector size 7. The first element, we will waste it. We will never touch it because there will be no such person called person 0. There will be only person starting from person 1, right? So now we can continue with the spread ones. Let's call it, maybe I should copy this one. It's returning a void. Anyway, let me put it here. It's returning a void, right? Spread 1. I have the person to start with. I have the relationship, and I have the person who knows it, right? Because I want to modify the know, so I make it a reference. Okay, wait a minute. It's a yeah. So here I need to implement how one person spread to all the other people who knows it. So it's basically we are iterating through all the relationships, right? And assuming we are iterating them, const this one, reference relationship R in relation, right? This one is the iterating, right? We're iterating all the elements in your relationship because the relationship are a factor of factor int. So each element is a factor int, right? Because we don't want to modify it, we use a const. Because we want to save some space, we use a reference. So R now represents each individual relation. It is, for instance, it's one line of them, right? It's one line of them. So in order to see that, let's see out, right? See out R of 0 and R of 1. Let's first test that. And how can we test it? We make this one comment out, make this one. Yeah. It really doesn't matter. But anyway, let's test this spread 1. Let's start from person 1, give the relation, and give the factor known. All right, so let's see what will be output. As you can see, because we only ask it to print, right? Print this relation, R0 and R1. So it basically prints out this relation, 1, 3, 2, 4, 3, 5, 1, 5, 6, 1, 2, right? So while you are writing your code, you can start debugging it. So in here, how can you spread it? You can say, okay, if the person who want to spread is equals to R0, right? If it equals to R0, it should have known of R1 to be true, right? If R0, yeah, because it's bidirectional. If it's equals to R0, the guy in your relationship, if it's equals to 1, then R1 known of 3 should be know it, right? And we can do the same for R1 and R0, right? If, because it's bidirectional, if R1 knows, then R0 knows. It is called spread one time, right? Once, starting from the person. Whoever you specify the person, it is doing this way. So we can also test that, right? If it's spreading, this one, let me put no of 1 to be true, right? If it's spreading once, starting from position 1, based on this relationship, and we want to figure out who knows after it, let's do it. You will see 1 knows, 2 knows, 3 knows, right? Because there's a 1, 3 and a 1, 2. So after one round, if it's spreading from the person 1, it becomes 1 knows, 2 knows, 3 knows, right? So that is something we have done. And also, indeed, we have already tested this spread once, right? We can delete them and start testing the whole function. If the whole function is correct. Is it correct or not? As you can see, spread 1 will modify the factor known, right? It is mimicking one round of spreading, starting from the person, right? So in here, if I am trying to spread once from person I, and it will reflect the result in no. Did you see the problem? Let me see. Let me write it down. The problem, right? This is my known factor. 0, 1, 0, 0, 0, 0, right? This is my known factor. And assuming initially I equal to 0 is wasted, so I can skip that. Assuming now I equal to 1. Now I equal to 1, right? I'm in the here and the first run, I'm in here and I equal to 1, right? I can spread. Because of this, no 1 is true. I can spread. I can spread to 2 and to 3. Now this guy becomes 1, this guy becomes 1. At the end of round 1, I equal to 1. No, round 0, I equal to 1. All right. So next time when I go back to this for loop, I becomes 2. I becomes 2, and no of 2 is also 1. I'm trying to spread from 2 to whoever is friend of 2, person 2, right? This is something I did wrong. Because if I ask it to spread only 1 round, I shouldn't allow 2 to propagate, right? I shouldn't allow 2 to spread to whoever is your friend. I should stop here. I should, yeah, so that's what we have to do it. And what we have to do is, instead of put it in here using the known, we of what is the known, what is known before the spreading of this round starts, right? We should keep track of that. We should keep track of the original known, right? Because this original known is the known of the 1 round before, right? At the end of the previous round. So it should be no at end of previous round, right? We should say no end of previous round. So if we can keep track of the known of previous run, right, we can use it to test, is this guy already known at the end of your previous run? And if the yes, we can spread, right? Otherwise, we don't spread. So that's basically what we can do. And let's test that after 2 rounds, right? It spread to 1, 2, 3, 4, 5 people, right? So that is the implementation. All right, so yeah, but this is just my implementation. Your implementation could be a little bit different, right? You could, so instead of using, for example, a factor of Boolean to remember who already knows, you can have a factor of integer to keep track of the index, right? Person 1 knows, I put 1 into my, for example, your factor. And then if 1 spread to other 2 people, then another 2 people put it into your factor.